we're going to take a look at 3 more chain rule problems that are a little bit more involved than the ones we looked at before, because they'll involve a few other tools thrown in there as well. The first one I want to take a look at is f of x equals 2x plus 5 to the 4th times 3x minus 1 to the 6th. Take a moment and just copy that down. What you should notice here is the big idea with this problem is it's the product of 2x plus 5 to the 4th times 3x minus 1 to the 6th, which means I need to go use the product rule on this problem. Now within there's going to be some chain rule that shows up, but the big idea is I need product rule. F prime of x is going to equal, well, according to the product rule, I need to do the first times the derivative of the second. The first is 2x plus 5 to the 4th. As for the derivative of the second, how am I going to deal with that? Hint, think about the name of this section. I need to use the chain rule on this thing. How do I do the derivative of 3x minus 1 to the 6th? Well, I'm going to do 6 times 3x minus 1 to the 5th, take care of that 6th power, and then by the chain rule, multiply by the derivative of the inside, so times 3. What I've done so far is my first times derivative of the second. This thing over here is the derivative of 3x minus 1 to the 6th. Plus, you take a moment and see if you can do second times derivative of the first. Okay, second is 3x minus 1 to the 6th times derivative of the first. Again, I'm going to have to use chain rule on that. 4 times 2x plus 5 to the 3rd. And then by chain rule times the derivative of the inside, so times 2. I'm going to clean this up a little bit. F prime of x is going to equal 18 times 2x plus 5 to the 4th times 3x minus 1 to the 5th. Over here, I'm going to get 4 times 2, that's 8, so 8 times 3x minus 1 to the 6th times 2x plus 5 to the 3rd. I still have a lot of simplifying to do. The good news is I'm done with the calculus part of the problem. That was actually what I did in this line. The rest of my work's going to be algebra, but some kind of messy algebra. What you should notice is there are lots of things that these two terms have in common. And I want to go and I want to factor out my greatest common factor. F prime of x is going to equal, well, first I'm going to look at 18 and I'm going to look at 8. And I think 18 and 8, their greatest common factor is a 2, so I'm going to pull out a 2. 2x plus 5 to the 4th, 2x plus 5 to the 3rd, the most 2x plus 5s that they have in common is 3 of them. So I'm going to factor out a 2x plus 5 to the 3rd. I'm always going to factor out a term to the lowest power that I have. With that in mind, 3x minus 1 to the 5th, 3x minus 1 to the 6th, I'm going to factor out a 3x minus 1 raised to what power? Hopefully you said 5th, 3x minus 1 to the 5th, because that's my lowest power that I have. I'm now going to deal with what's left. 2 times what would give me 18? 9. 2x plus 5 to the 3rd times what would give me 2x plus 5 to the 4th? Well, a 2x plus 5. 3x minus 1 to the 5th times what gives me 3x minus 1 to the 5th? Nope, we're already good with that. Plus, see if you can take a moment and go through that same logic over here on this piece to figure out, once you factor out your GCF, what are you left with from your second piece? I'm going to take out, let's see, not take out, I'm going to think if I was distributing 2 times what gives me 8, 4. 2x plus 5 to the third times what gives me 2x plus 5 to the third, already good there. 3x minus 1 to the fifth times what gives me 3x minus 1 to the sixth, well, a 3x minus 1 to the first. But it's not okay to leave an answer partially factored and partially, well, expanded with a little factoring as well in there. I need you to take a moment and just clean up the stuff inside these parentheses. Distribute, combine like terms, and then we should have our final answer. I'm going to get 2 times 2x plus 5 to the third times 3x minus 1 to the fifth times 18x plus 45 plus 12x minus 4. I'll combine like terms. 2 times 2x plus 5 to the third times 3x minus 1 to the fifth times, let's see, this looks like 30x plus 41. And that is my derivative, fully simplified, which is what the direction will always be with problems like this, to simplify it fully, to factor out as much as we can. Why? 2 chapters from now, we're going to deal with taking derivatives and setting them equal to 0 and dealing with things like that, which is not easy if you're expanded like this. But if you're fully factored, it'll be very easy to set the different pieces equal to 0 and solve. So I have 3 total chain rule problems I want to show you here, and they go in order hard, harder, hardest. So this was the tough example. Let me show you a tougher one. F of x equals x squared times the square root of 1 minus x squared. Take a moment and copy that down. So taking a look at f of x equals x squared times the square root of 1 minus x squared. I'm first going to rewrite it as f of x equals x squared times 1 minus x squared to the 1/2. And then I'm going to go use the product rule on this once again. I'm going to get f prime of x equals, first, x squared times, see if you can go do derivative of the second. 1/2 times 1 minus x squared to the negative 1/2 times negative 2x, because we have to use the chain rule on that piece. 1/2 times 1 minus x squared to the negative 1/2, that took care of the 1/2 power, by chain rule times the derivative of the inside. It's only half my product rule, though. Now, plus second times derivative of the first. See if you can go do second times derivative of the first. Second, 1 minus x squared to the 1/2 times 2x. I'm going to clean this up a little bit. I'm done with the calculus, but I do have a bit of algebra that I'm going to have to do to clean this thing up. 1/2 times negative 2, that should give me negative, let's see, 1/2 times negative 2 is just negative 1. X squared times x is x cubed, so negative x cubed times 1 minus x squared to the negative 1/2 plus 2x times 1 minus x squared to the 1/2. But now I have some GCF work to do. Negative x cubed, 2x, they have an x in common. I'm going to take out an x. As for the rest, 1 minus x squared to the negative 1/2, 1 minus x squared to the 1/2, Our rule is we always take out the factor to the lowest power. In this case, that lowest power is a negative power. It still works though. I'm going to take out a 1 minus x squared to the negative 1/2. What am I left with after I take out that GCF? Well, x times what would give me negative x cubed? I think I can do a negative x squared over there. 1 minus x squared to the negative 1/2 times what gives me 1 minus x squared to the negative 1/2? Nope, good with that piece. X times what gives me 2x? 2. And then 1 minus x squared to the negative 1/2 times what gives me 1 minus x squared to the positive 1/2? Well, I'm going to get 1 minus x squared to some sort of power that I'm going to figure out in a moment, because that's a little too complicated for right now. Remember that when you multiply variables or terms like this, we add our powers together. So really I have to ask myself, negative 1/2 plus what would give me positive 1/2? Negative 1/2 plus what would give me positive 1/2? Well, just 1. Actually, this power over here is just 1. If you're not seeing that, different problem. Y to the negative 1/2 times y to the what equals y to the 1/2. It's a little tricky to read. Y to the 1/2. Well, we need to add our powers. We get y to the negative 1/2 plus something equals y to the 1/2. Negative 1/2 plus what gives you positive 1/2? 1. That's where I'm getting that power from. Now I just have a little more cleaning up to do. F prime of x equals x times 1 minus x squared to the negative 1/2 times negative x squared plus 2 minus 2x squared. F prime of x equals x, 1 minus x squared to the negative 1/2. I'm thinking 2 minus 3x squared is the piece that's left inside those parentheses. You know what? I probably shouldn't have put a box around that. We shouldn't be leaving negative powers, so I should move that to the bottom of a fraction. I'm going to say x times 2 minus 3x squared over, you could say 1 minus x squared to the 1/2. If you want to be fancier, you could say a root in your denominator. So something sort of like that. I have one more problem to show you, and as I told you, these 3 problems we're going to go tough, tougher, toughest. The last one is as tough as I'm going to make these. Let's take a look at f of x equals x over the cube root of x squared plus 4. F of x equals x over the cube root of x squared plus 4. And I'd assume you look at this and say quotient rule. However, what's easier, product rule or quotient rule? Just in general, which one is easier to use? I hope you're thinking product rule is an easier thing to use because there's no draw the line square below that part over there. Instead of dealing with this problem as a quotient rule problem, which is going to be plenty ugly in and of itself, I can make it a little bit better at least by turning this into a product rule problem. As a quotient, this is x over x squared plus 4 to the 1/3, but I can make this into the product, x times x squared plus 4 to the negative 1/3. And that's going to be a lot easier for me to deal with. Now, I need to use product rule on this with some chain rule stuck inside there. I'm going to make the video pause, see if you can go write out your first times derivative of the second, using chain rule, plus second times derivative of the first. first is x times derivative of the second is negative 1/3 times x squared plus 4 to the subtract 1 from the power, you're going to get a negative 4/3 there. And by chain rule, times 2x plus second, x squared plus 4 to the negative 1/3 times derivative of the first, so just times 1. We clean this up. F prime of x equals negative 2/3. X times x is x squared times x squared plus 4 to the negative 4/3 plus x squared plus 4 to the negative 1/3. I have to factor out my GCF. F prime of x is going to equal, well, there's no x up front that I can take out, so that's just going to have to stay. I'm going to factor out an x squared plus 4 to which power? To the negative 4/3 or to the negative 1/3? Always to the lowest power, so I'm going to take out an x squared plus 4 to the negative 4/3. I'm then left with negative 2/3 times x squared times the x squared plus 4 piece is totally gone there. Plus over here, I've got x squared plus 4 to the, gotta figure out the power. Negative 4/3 plus what would give you negative 1/3? It's gonna be 1, just like it was in the last problem. And in fact, it's always gonna be 1 with these. More cleaning up to do. F prime of x equals x squared plus 4 to the negative 4/3 times negative 2/3 x squared plus 1x squared plus 4. Should combine like terms. This one is really like a 3/3. F prime of x equals x squared plus 4 to the negative 4/3 times negative 2/3 plus 3/3 gives me 1/3 x squared plus 4. I shouldn't leave a negative power, so we can make this f prime of x equals 1/3 x squared plus 4 all over x squared plus 4 to the 4/3. One last little issue though. I'm not allowed to leave a fraction inside a fraction. I'm going to go and multiply the top and bottom of this by 3 to turn this fraction into something that's not a fraction. I'm going to have to go and distribute the 3 though to both of those pieces up top, and we're going to get f prime of x equals x squared plus 12 over 3 times x squared plus 4 to the 4/3. And I think it's fair to say that that's about as tough as these are going to get.